Okay, so now let's look at problem number 4 on test review 7. This again is a case of nonlinear equations, and we're solving it graphically. And so notice in the first one we have a square root. Now we could do just our classic transformation rules that says, you know, if you have the positive on the inside, it makes it move to the left. And so we get a clear center, but I almost think for this one it might be best just to go classic and build a table. Now the nice thing is it's already set up for y, so we could, if we wanted to, just put it in our y equals in our calculator and build a table that way. That's fine. I'm gonna go ahead and build one real quick. When I put a 1 in for x, that'd be negative 1 plus 1 would give me 0, square root of 0 is 0. And this 0 plus 1 would give me square root of 1, which is 1. 3 plus 1 would be 4, square root of 4 is 2. And so all you can clearly see is I'm just input, output, putting in a value, getting an output. And so I'm going to go ahead and graph that one. So we have negative 1, 0. We already knew that with our transformations that it would start there. But here we're getting just more specific, not just your willy-nilly 0, 1, y-intercept, and then we have 3, 2, and you can see it kind of coming together. 8 is down here, 8. 3 would be somewhere right here. And so we get our classic square root property. Now, notice the second equation is a classic linear. I went ahead and I put all this down because it was already solved for y equals mx plus b. So I have a slope of 1 over 1, up 1 over 1, and I have an y-intercept of 0, 1. So we can clearly see we can go up 1. You know, we get a y-intercept of 0, negative 1. So 0, negative 1 would be right here. Oh, that's my y-intercept right here. Sorry, forgive me. Slope 1 over 1, up 1 over 1, up 1 over 1, up 1 up, down 1 over 1. And so you can see it kind of coming together. Here's our linear line. That's equation 2. Now, this one's not going to have two intersections like our circle did because here it can't go past this point, and so it's not going to ever go down here or anything like that. So this one, in fact, only has one intersection point. It's still a consistent system, and the answer would be 3, 2 right here. That's our answer. And like I said, it's a consistent system. Let's take a quick look at number 5. This one, again, same concept. I'm going to approach it using my table building skills or, of course, your calculator skills. I don't know why it's getting blurry all of a sudden. There we go. And so I went ahead and set it up. We have y, my equation 1, my equation 2. Again, here I kind of rushed through it a little bit and went ahead and did my y equals mx plus b because that's kind of a review concept. Technically, so is this, but I feel like this one we need to go ahead and build a table, get some more exact points here. It's a little bit more tricky. So negative 2, if I put a negative 2 in here, negative 2 squared would give me a positive 4, but the negative 4 minus 3 would give me negative 1. Again, you can get this table very easily off your calculator. I'm just going ahead and acknowledge. And so let's go ahead and build this quadratic, and we know it's going to have a parabola shape. That's old school material. We should know by now. Negative 2, negative 1 right here. Then we have negative 1, 2 right here. We have 0, 3. There's my vertex. 1, 2 right there. 2, negative 1 right here. And so here's my classic parabola, put an arrow on both ends, and then we have, of course, your friend and mine, our linear, y equals mx plus b. It starts at 0, 1, and it goes up 1 over 1. I'll look at right there. I'm gonna go down. There's our other account. This one, in fact, has 2 solutions. It intersects at 2 places, and so my answer for this guy using the graphing method is negative 2, 1, that would be right here, negative 2, 1. And I also have 1, 2, that's this intersection right here. Of course, you know we can solve this using substitution, or we could have solved this using an elimination system, but in this particular problem, it asked us to display it using graphing. And so here is our graphical display of a quadratic and a linear, and where they meet is in 2 places.